wanted to point out, I've done some previous tutorial work in Unity for the past classes that I've TA'd. So this, you can look up here at my GitHub repo. I have them put on the front page of mine, just BR Holtkamp for GitHub. So in fall 2016, Cougar CS asked me to come through and do actually no, wrong one around. So in fall 2016, IEEE, the chapter here, asked me to do a tutorial series. So what I did is I put together Super Mario Brothers World 1-1 in Unity with like enemies and all that stuff. It's not the prettiest, and it isn't exactly what it looks like, but I purposely made it with 4 different lessons. So I did 4 different seminars on it to cover sort of different facets of the engine, and I have write-ups here that go into detail of like, essentially step by step. I didn't get any good audio recordings of it, but these sort of go through and say like introduction and like step by step of what I'm doing and the lesson plan and where I'm clicking and all that stuff. So those tutorials can go through, you can look at them, and if y'all aren't familiar with Git too much, there's branches for the progress through each lesson. So y'all can go through and say like, oh, I want to see what he was doing between lesson 3 and 4. Go pull down lesson 3, and you can see what it was before, and lesson 4, and see what happened after. So that's one I have available. It's pretty much your run-of-the-mill platformer, some really basic enemy logic, some basic physics collision stuff. For spring 2016, after doing that one, they wanted me to go through and do a, like, for everybody, no game dev student, super beginner to Unity one, which I went through and just remade Flappy Bird in Unity. So super easy, construct a game object, make it move across the screen, track score, reloading scenes, some of those sort of core concepts that you have to do in Unity when you make like a game that you'll die pretty quickly. Also in there, sort of cover how you go through and you adjust it piece by piece by piece. It's meant to be sort of an independent one if somebody didn't attend the lecture. And lastly, I have up here 4358 demos. Inside this one, I have little call-outs that people were asking for help on, like how do you do audio mixing, how do I make a local multiplayer game, how do I build an inventory system. Some of those ones that people called out in past classes, I'm just like, oh, hey, I can mimic that pretty quickly and get y'all something to see. So those are like, mostly they're just cubes that change color and very, very simple, but I go into a little bit more detail on like how they're architected, how to use some of the more advanced stuff in Unity, like scriptable objects and interfaces that y'all might not be familiar with. So all these, publicly available, free, go pull them down, go give them a shot, all under my GitHub repo. So I wanted to go through and just show y'all this as an additional resource available to you. It doesn't supplement like the actual nice Unity tutorials where everything actually looks nice and doesn't completely break, but it's still something that you can work with. So yeah, any questions before I get started into game engines and such? Cool. So far y'all have supposedly done tutorials and y'all have started working on your game. I could go through and start talking game design, or I could start talking game architecture. Where would y'all want to go first? Y'all feel like y'all have a comfortable understanding of what your game is? Okay, cool. So I can go through and skip past some of that. Oh, any other question? I thought you raised your finger, my bad. So for a game engine, does anybody feel like they have a comfortable definition of what a game engine is? Okay, you nod your head. Okay, what is it?
It's similar to like an IDE. It's an environment in which the rules of the game are built upon, I guess.
Yeah, like it is just a framework for you to work off of. Here's a bunch of tools. I will give you documentation on how to use these tools and put them together to build your game. And rule is a very good thing to bring up because when you're thinking about a game, think about any sort of game that you've gone through and you've played and suddenly something weird happens, like some physics freaks out or your character gets like, I don't know, if their legs for some reason stretch weirdly. When you look at those things, you sort of are seeing the two different sides of a coin that a game is built out of. For games, they're essentially the simulation of the game and the presentation of the game. So when it comes to building a game, you want to go through and first figure out, do your rules make sense and are your rules able to function correctly? That is your simulation. So if you want to go through and look at some of the R&D stuff that Nintendo does, Nintendo builds out most of their Mario games with cubes. Straight up. Because they want to go through and make sure the jumping feels good, the climbing feels good, all the mechanics feel good, and that they are simulated correctly before I start throwing art into the mix and making it even more convoluted. So the simulation of your game is what you need to get right first. So that's why we always use placeholder assets. That's why we always use just like crummy textures, really poor models, and we do them in iterations because we want to go through and see if we start building up this game, do our game rules make sense? Do they behave correctly in the engine? Does my physics feel good? Because like there's like a bunch of teams who are doing platformers. If a platformer doesn't feel tight and doesn't feel good, nobody's going to want to play it. So you want to go through and get that simulation down right. And then converse to that is the presentation. People don't want to go there and spend $20 on Steam getting a game that's a whole bunch of cubes. Like we've seen all the shovelware getting pushed on Steam that are just a whole bunch of default assets. We want to go there and see the presentation of the game. So that's getting your aesthetic down, that's getting your particle effects, all the tweens, all the stuff that go there and make your game atmospheric and feels good visually, like your menus and all that stuff. So that happens to be what you want to be using update for. So whenever you think about presentation, I don't care if my character is running this way, if like for some reason it stutter steps. Because as long as my collider's in the right spot, the game is behaving correctly, and me as a player don't feel cheated that, okay, maybe a graphical glitch happened, but I didn't die because of it. I didn't go there and fall off a cliff because of it. That presentation part is where you want to be putting inside your update loop. Conversely, the simulation is what you need to get right. That's where fixed update comes in. Has anybody actually seen fixed update so far in any of the tutorials? Okay, that's what I expected. Whenever I first started this class, I didn't know about fixed update, and I was building a platformer, and I found out that working on a laptop, where it was a bit slower, and then working on my desktop, which was a bit faster, I had some weird discrepancies in my physics, and I'm like, what the hell is going on? And it's because I was simulating it on the frame rate, and something wasn't going right. So, I have a really good example of that. Dark Souls. Dark Souls was originally built for consoles, and it was originally built with a 30 FPS cap. So when it came to PC, and PC people don't like dealing with 30 FPS games and ports, so they went there and hacked it to make it 60 FPS. And this is what ends up happening. And now you have been cheated and you die. And sure, you're gonna die a lot in Dark Souls, but you shouldn't be dying like this. So that is where the simulation and the presentation, they have crossed those boundaries and become more convoluted. So yeah, let's get back to good old algebra. Let's look at, oh wow, great. Okay, take two. Not much better, but sure, I'll work with it.
Right.
Yeah, oh, okay, that works.
And an eraser.
Okay, I'll just try it over here. Can everybody see this one pretty good?
Yeah.
Okay, sweet. So, anyone remember doing the timing graphs and stuff like that in algebra? Where you go and you see the nice little line and the arrow and all that? So, a game works on this particular model too. So, say you're going through and you're doing this sort of game, your game's chugging along just fine at 60 FPS. This is really nice and reliable. Say I go through and I do an item glitch in Oblivion and I get 4,000 watermelons in my scene. You're gonna go there and see this super long frame rate where this is all happening right now. And so it takes, the game now, it's like going like 1 or 2 FPS. So say that this is the frame of 1 second. This is 1 6, 1 6, 1 6. By the way, in Unity, this is time.delta time, this value right here. But in this case, it's like 5/6 of a second is 1 frame. And now my game is like jittering along and it's laggy. If I go there and I put my physics up here, if my character's moving at this speed, but suddenly moves it at this speed, I'm going to either teleport or I'm going to go short, and that's exactly what happened on there. We saw the capsule of the player right here on this tick, and then right here on this tick, and well, I never touched the ground, so I'm just going to keep falling. That's what the game rules told me to do. So because of that, I'm going to keep simulating. And since I bound it to FPS, I'm going to go through and fall through this terrain. So sort of the pattern that you want to be doing in Unity and other engines is on the frame rate, pull for input. So call your input.get key down, or call your input get mouse button 0, and then store that somewhere, and then consume it inside a fixed update. So you want to go through, and so for anybody doing 2D games, you might want to go through and use like a vector 2 and store the X and Y of the player's control stick. And then on the next fixed update, take that and move the character. So that you go there and you make sure that this guy is going at this frequency. Oh, I guess I skipped past the point of, on update, you're going to this frame rate. Unity has fixed update, which is going on a steady 0.022 every single moment of the game. If your processing takes longer than 0.22, it's going to drop the frame and just pause the game, and you're not going to move anywhere. So it guarantees that your simulation is always going to be correct. So you're going to keep rolling through this, and making sure that your game rules behave accordingly so that your player doesn't get cheated just like that. So, any questions on that so far? Cool. Okay, so I needed to get through that particular part because, as I saw, only like 5 people raised their hand for fixed update. Now we can get back into the actual gist of the engine. So, when you're working in a game engine, you have this collection of tools available to you, like physics and rendering and all those particular pieces. And as y'all see, that y'all had a whole bunch of mono behaviors that are available to you. So Unity is built around what's called a entity component system. So you have entities and you have components. So every time you right-click, make new game object, or in Game Maker, I think they call them actors. I can't remember off the top of my head.
Objects.
They just call them objects also?
Yeah.
Okay. So each one of those is a entity in your game. So as you construct them, those are things that are representing a collection of components that exist in your world. And that's why every time you add one, you have a transform component added to it, because otherwise, I just have this thing that exists and has no physical location in my world. So as you start building out your game, you want to start thinking about what commonalities you have within your code that you can go through and use in multiple different spots. So say I want to go through and remake Super Mario Brothers. So what are the enemies in World 1.1 of Super Mario Brothers? Goombas, Koopas,
Piranha Plant.
and Piranha Plants. So for those 3 enemies, which ones of them move?
The turtle and the Goomba.
Yeah. So turtles and Goombas both move. Do they move the same way?
No.
They don't. So when you start breaking that down, so we have, let's clean this stuff off. So we have the Goombas, which can move, and we have the Koopas, which move, and then we have the Piranha Plants. So what do the Piranha Plants particularly do?
Up and down.
Up and down. So they have another movement behavior. So up,
You
down.
can just make an animation.
What's up?
Yeah, that could, you could just make an animation with the moving collision points.
Yeah, that's the correct way to do it, yeah. So when you look at this though, we see these commonalities here. So why do we need to go through and reinvent the wheel and write the same movement code in 2 spots? You don't need to. So because of that, that's why you need to start thinking in components. So whenever you're thinking in components, you're thinking of what is the common behavior that is shared across my game. And so by breaking those down and figuring out sort of, like just think about your enemies as you're building your game and just put under them bullet points of, this is what I wanted to do. I wanted to have a melee attack. I wanted to have a ranged attack. I wanted to chase the player. And when you start seeing those ones that are all common across them, circle them and start thinking about how do I make them into a common component. So if I'm wanting to go through and make a Goomba and a Koopa, they both behave differently. But they both move just in a lateral fashion across the world. So this can be the thing that handles the lateral movement, but it can't be the thing that handles how it behaves when it moves. Because Goombas, they only walk in one direction, while Koopas, they will walk until they find an edge and then turn around. So whenever you go through and you think of that, those 2 can't be shared. So what you have to do from there is make an additional AI for each one. So this will be AI Koopa, AI Goomba. So because of that, these 2 can't be shared. So when you start breaking these guys out, Goomba will probably be, we'll have a collider, a rigid body, then it has a movement, sprite render. So you can go through and you start listing these out, but this looks exactly what it should look like on the right side of Unity where you have your inspector window. So if you start going there and mapping out your game, which is the point of the GDD, if you go there and map out what your enemies are, map out what your player behaviors are, map out what your weapons do, map out like even your visuals that you can recycle and use, you end up cutting the amount of work you have to do in multiple magnitudes less because you can just recycle and reuse. So saying that though, if these two are different but they're using the same movement, how do I utilize that? So in the tutorial that I brought up over here, you end up just having a dot move on the component. And you just give it a value between that -1 and 1 that moves it from the left or the right. That's all you have to do is just say, okay, I want you to move in this direction. And it will go through and get the rigid body or get the collider and go through and do the rest of the work. And so by going through and recycling this, you end up doing less work, because I've seen multiple teams go through here that they're just like, oh, a new enemy, I'm making a new script, and I'm doing copy and pasting a whole bunch of work in there. And then say you go through and you start writing this out and you find out that, oh, if I give a 1.1 accidentally and my Goomba starts flying across the screen, I now have to go back and fix that for the Koopa and fix it for all the other enemies that I've made based on that previous code. So save yourself some heartache and go there and start working on those components and just recycling them as much as you humanly can. So that's the way that Unity expects you to go through and start architecting your game. So think about it as in, I have those entities that are just things in my level, and I have components that give it the capabilities and the features that they need to do their job. Any questions on that so far? Okay.
So would we use sort of like an inheritance thing where we have like a superclass script and then we pull input from that for the specific AI?
Yes, you could. So does anybody plan on making more complex complex AIs in your game that I would chase and then get lost or those kinds of things? Anybody planning on doing anything like that? Okay, so if you were going to, you could go through and make a base class that is all like a state machine. Has anybody ever used state machines before? It's covered in the automata classes, if I remember correctly.
Theory.
Oh, in theory?
Theory, yeah.
Okay, so when you start thinking about it that way, you want to go there and have this particular, I have my idle state, then I have my chasing state, then I have my attacking state, and all those particular things. Don't repeat yourself and don't introduce more bugs into your code. Write that into one core class and then extend it and add in the additional features that you need later on. So just use that, use all those coding things that you've been taught up till now to make your lives easier, because y'all have to build a game in 2 months now? Yeah, it's a daunting task. Y'all have a lot ahead of you. So try to make it as forgiving and easy on yourselves by going there and using all those skills that you've been shown so far. And honestly, when I came into this class, and I came into it as a grad student, I didn't feel confident using a lot of those skills because I had not really gotten to use them in anything bigger than just a couple 100-line projects. So this is a good class where you go through and you can explore that and use it with whole lots of examples in front of you and go there and try to really flex those muscles and get them something that you're more familiar with as you're doing this. So always feel free to go through and ping me for help on any of that stuff, because those are all available to you and they will help you achieve what you want to achieve in this class. So any other questions related to entity component system? And also, if you end up Googling for that, be aware that there is entity component system and entity component system. There's the 2-word plus system and then 3 words that are ECS. They're 2 completely different things, and Unity's implementing ECS. I would not recommend going down that path. It is highly complex and it is probably way outside the scope of this course. So that's an unfortunate thing that Unity's been producing in the last 2 months that's poorly marketed. They're now calling it the dot system to get around that. If you end up bumping anything that says ECS, just leave it over there. I wouldn't recommend doing it because it is a giant architectural system that if y'all want me to talk about it, I'll talk about it one-on-one with y'all later, but it's a whole thing just so that if you start Googling, you don't bump into anything too crazy. So getting more back into engines, go through and really break up your code, use the frame rate to your advantage. Going from there, has anybody seen the serialized? Oh, sorry.
So, I know that you already know this, but don't the Koopa shells usually sort of pop up when you stomp on the turtle? So that would just be another line of code of if Mario kills this thing, shell pops up?
Yeah. So the question was, talking about, so if I were to go through and continue building out the Koopa behavior, how would I go through and do the shell part of the Koopa? So what you could do is have that be another child in the hierarchy. So you can have it set up as in, you have the Koopa, then you could have the like Koopa alive and Koopa shell. So say it's alive, it's running all this code, and it's 2 tiles tall, it moves to the side, looks for gaps, turns around, it bumps into Mario, kills him. Or you could go through and make it into the Koopa shell whenever it gets hit, so you could turn off this game object and turn on this game object with game object.set active. And by doing that, you now have, this is the one that's deeming what kind of behavior it has. And it can have its own separate controller, its own separate collider and rigid body and all that. And it can be the one that actually moves it around. So you can go through and use that hierarchy to your advantage to go through and say, okay, I want this Koopa that's in this location in the world to do something else, stomp on it, turn on the other one, and let it now become a shell. So you can use that to your advantage and go through and have it, and even you think about it like, say if you wanted to take on building like a Super Mario Maker, you can just leave this guy as another prefab that you drop into the level somewhere. If you wanted to have a shell, that's always a shell for some reason. And you can just recycle it and you get it for free, because you've already implemented it here. So use all that stuff to your advantage. And just have your logic in here that says, okay, if that happens, go to my parent, find the shell, and then turn that one on and turn me off, kind of thing. So you can do that kind of behavior to get that job done. Any other questions? Okay, so we covered that. I guess I could talk a little bit more about the hierarchy. So Unity uses a hierarchy, while Unreal uses a world outliner, while Godot uses a sub-scene system. Those are all sort of different ways to describe relationships between objects in your world. So when you look at Unity, you see the scene that you load in, and it has a collection of game objects, right? So those are game objects that have transforms that place it in locations around the world. So whenever you start tithing stuff to game objects, you now establish a relation that when this parent moves, this child is tagging along with it with this transform of distance between it. So you can use those things to your advantage a lot. Say I wanted to go through and make a game that is a knight that goes and picks up a sword, and maybe the sword breaks after 1 hit, for example. You go there, make the knight character have a game object that represents the hand, and whenever it collides with the sword, make that a child of the hand, and now you don't have to bother with all the animation code because the hand does the rest of the work. Because the sword is just attached here, and anytime the hand moves, the sword moves with it. So when it comes to doing like equipable items or picking up enemies or any sort of behavior that involves 2 entities in your scene interacting with one another, you can use parental relations to go through and get that done by moving them around in the hierarchy by calling set parent on the game object. Another way to do it, say for example, you had a situation of, I need to have 2 things together, but they happen to not, if they end up being parented to one another, you have some weird conflicts of like, I need to look through, say for like an ammo belt kind of situation where you need to have a bunch of random things that are attached to it, and you need them to be physically there, but they need to have like their own collisions or something. You can use physics joints. You can use like a rigid joint or a spring joint to associate them, but not establish the parental relation. So those are 2 different tools you can use to attach stuff or at least establish some sort of movement-related relationship between 2 objects in your scene. Oh, what's up?
So, I'm guessing these are game standards and not Nintendo tricks.
No, they're used everywhere.
Okay.
So, so something that I don't know how to say this without being too out there. Every single game designer cheats all the time, right in front of your face. So who's all played Fallout 4? So remember whenever the Vault-Tec guy comes to your front door and has the little clipboard in his hand when you're doing the character creation? You know what that actually is? It's a shield. It's a shield from the Skyrim code that has just adjusted the art so that it ends up in his hand. The reason why they did that is because they already have something really reliable, because Skyrim has tons of shields that work reliably and get attached to actors' hands. And why reinvent that? Why not reuse something that already works, already is tested, and has been tested for at least 5 years before, and use that to my advantage? So all that they did is they made a clipboard asset that was a shield object, and that was just adjusted back into its hand. And that's all that they did. They cheat right in front of your eyes, and as long as it looks right, as long as the presentation's good and the simulation is good, the player's none the wiser. So when it comes through and doing like cutscenes or things like that, if you go through and actually have like jump into console or something and control the camera, you'll see stuff getting turned off in the distance because they want to have a really fancy explosion happen and they don't want the frame rate to drop. Game developers cheat all over the place. So when it comes down to that, you have a bug or you have a particular part of your game that just the frame rate is terrible, which I'm going to assume that most of y'all won't run into frame rate issues in this class unless y'all are doing like some really complicated stuff in 3D. But if you end up having an issue where like this thing just doesn't seem right, but if I just turned off this like pillar that's in the way, I'll get the effect that I want. Just write a script and do that. Just call it in the middle of your cutscene and get the job done. As long as it goes out the door and gets in front of y'all's customers, which happen to be the judges at the final presentation, it worked. And it did exactly what it needed to do, and you got the job done. So I say the word cheat, and I mean it, because they go through and they have to find a clever way to get the job done, and that's how they do it. So that's always available to you. You can always plan to do it right, but you always have to do the cost-benefit analysis of, do I write this code perfectly now, or do I get the job done and then I revisit it later whenever it matters? Those are always the balances that you must figure out to essentially survive this class. And it's an art form. I can't give you any good answers to do it because I don't feel comfortable with it myself, because I'm just like, I'm more of an engineering focused person. I write code for a living. I want to write the code right. But when my boss is saying like, oh yeah, that thing's like due yesterday, I just have to make it work. So when it needs to go out the other end, there's tons of duct tape attached to it to make it work. So getting back to the question, sometimes it's tricks, but as long as the tricks work, it's not really a trick, it's a feature. So always keep that in mind. So any more questions related to using the hierarchy or anything like that to get the job done? Got it. So pretty much going more into the engine, is there any particular systems that people have had questions on, like physics or rendering or anything like that? What's up?
It's about just the components and objects. How does the layering of the movie work from the object layers?
Very good question. So everybody's seen the little thing in the top right that says layers, right?
Yeah.
So those layers give you a bunch of information about this object. First off, it's used in rendering and it's used in physics. So y'all might not have seen it yet, but if you go into Edit, Project Preference, or Project Settings, Physics or Physics 2D, there's a giant grid there of checkboxes. And what it's showing you is that, say I have, for example, I have NPCs and I have player characters. And I'm making a game like Shovel Knight where I have like a town scene where I can walk through characters and talk to them. I don't want Shovel Knight to bump into the NPCs and push them around. I want to just pass right through. So, but I need physics on both of them because I need to know like, am I grounded and all that other stuff. So I can put them on different layers and turn off physics collisions on those layers, and they will just pass right through just fine. So those layers give you the ability to say, this is this type of physics interaction that I want to have, and these are those type, and I don't want them to collide, or I do want them to collide. I want my enemies to always collide with a player, but I don't want enemies to collide with other enemies. So I can go there and use that layering approach to give myself I can assign them the according behavior that I want, and make it behave accordingly by adjusting the physics system to do its job. Another thing you can do with that is you can also use the tags that are right beside it to go there and give additional information on what you're bumping into. So say for like the knight example from earlier, I want the knight to be able to pick up weapons, and I want the knight to pick up armor. When I walked over them, they might collide with the item layer, and I now know, oh, I had an item collision. I can then look at the tag and say, is this a weapon or is this armor? Does it go on the chest mount point or does it go on the hand mount point? And I can go through and use that tag that gives me just that little bit of additional information, but it's still an item per se, and get my job done. Second to that, when it comes to layers, is that you can use multiple cameras in Unity. The multiple camera approach, you get to choose when things render. So say you want to go through and you want to build a 2D game that you have a foreground and a background and then the layer that the player is walking on. What I can do is I can say this is in the background layer, this is in the foreground layer, and render the background layer first, then my player and my enemies, and then my foreground right after it. So by using 3 different cameras that all are like set to the same spots and set with the same sizes, I can go through and get that sort of layered effect without having to adjust my Z levels and all the other stuff with my transforms. I don't have to bother with any of that. I can put them wherever I want, and my camera just behaves accordingly. So by using those multiple cameras, using the layering system to your advantage, which I'm pretty sure GameMaker has that in Godot, I want to say does. You can use those to your advantage and say, I want these things to render in a certain order so that I get the visual effect that I want. And you can also use them for physics and make your simulation happy too. There is also, for 2D people, there's sorting layers, which essentially say, when it comes to 2D objects, they all get rendered on the same Z layer. It'll go through and tell you, essentially the ordering within that one layer you want them to behave. So you can go through and say like, I want the enemies to always be behind the player, but they happen to be on the same camera render. I can go through and use sorting layers to get that job done. There's a bit more quirks with them. I would recommend going to the documentation. They have a really good like image example with some zombies that shows like, they have a zombie that's multiple segments. You have like the foot, the leg, I guess the ankle and the leg. And they want to make sure that the foot goes to the back, then the ankle, then the leg on top so that you can see that joint really nicely. They use the sorting layer system to get that job done. So I would recommend going to the sorting layer documentation on Unity to see a good example of that. I don't have the visuals to really show it effectively right now. Any other questions related to that? What's up?
So just one thing I want to know more about was like the materials component of physics objects. I haven't,
Oh boy.
Yeah, I'm sure that's a big question. I noticed, I looked at it a little bit, I saw that you can adjust like friction and stuff like that. For platformers, is that primarily used to, have like icy floors or, I don't stick to things?
There's 2 different ways to do that. It depends on, so I guess this is a good topic to get into. How many games have people played use realistic physics? So the ambiguity is on purpose because realistic physics typically doesn't feel good. So whenever I want to go through and play Super Meat Boy, I don't want that to be realistic physics with tons of inertia because that's going to be, I'm going to die a whole lot playing Super Meat Boy.
Or Borderlands.
Or Borderlands. Like there's plenty of reasons to not use realistic physics, but there's some situations where it makes sense. So those physics materials give you the ability to control friction and bounciness. The blue slime from Portal 2, you go through and attach that to this particular platform and suddenly you get a bounce effect with your collision logic. So you could write that yourself. The physics is out there, you can use it's typically like physics 1 level stuff that you just use the formula. You can go through and implement it yourself if you want to manage your physics to that amount. Like say you wanted to make it where every time you bounce, it always goes back to the same amount instead of losing momentum. You can use that by writing it yourself, but if you don't care about it being that particular, you can use the built-in one to get the job done really quickly, because then you just drag, click, click, you're done. So getting back to the cost-benefit analysis, you could do that to get the job done. Those are the 2 available in 2D. There is some stuff in 3D, but I'm not too familiar with using physics materials in 3D myself. They're all available to you. Click on the point I was going to get to after that. It's just an additional asset within the physics system that's available to you. Use it just go through and experiment with it. You just go there, make a new scene, put in some platforms, drag in your player prefab, and just let it use those physics things to see if it makes sense. Oh, sorry, getting back to realistic physics. For those of y'all who are doing platformers, or any of y'all planning on doing it the best example I have is the older Mega Man games where you see you can tap yourself off the edge. Those kinds of things where you see the tip of the toe is somehow on the very edge and somehow he's still sitting there. One thing to look into is there's raycast available. So in physics, there's a raycast method that what it does is it says, hey, I'm gonna shoot a laser over there in that direction and tell me if I hit something. So for a lot of the classical platformers or highly precision focused platformers, they use raycast by the edges of the collider to go there and see am I touching the ground or not. And they use some segments in between of more additional rays to go through and determine, hey, am I touching the ground in this way? By using those, you get the ability to go there and say, like, what am I hitting, what am I hitting, what am I hitting? And I give it just a really short little laser to see what I'm colliding with. By using those, you can go there and control the rigid body by saying, okay, I'm going over here. You're wanting me to tip off, but actually no, I'm just gonna say my velocity is now 0 because I'm still touching something on the floor. You can use those things to your advantage. There's a really good tutorial. It's a little old, but where's it at? There's a guy called, yeah. So like he's done some of the tutorials for Unity, and he's got an older one for building a 2D platformer with only raycast. It's somewhere in here. I would recommend his stuff. He's actually got some pretty good videos on it. But he goes through and he does it with raycast to go through and get that sort of classical platformer feel, so that you can go and tip your way over the edge, or if you bump into like a slope, you sort of are standing offset to it, so that you're still like upright, but the platform does let you slide up. He goes and shows you the map behind that, so that you can get the job done if that's the particular feel and aesthetic you want for your game. Those can also be useful for detecting like line of sight. So say if I want to go there and have like a guard enemy that goes through, and if there happens to be a perfect line of sight between the head and my character, I can be using a raycast and firing at the player's position at all times. If it doesn't collide, or it's a shorter length and doesn't hit the player, I haven't seen the player yet. But if they get close enough and the raycast returns true, then I have seen the player and I can go through and start chasing them. So they're mildly expensive. I would not recommend going over like 1 to 200 of them per frame for most computers. So go there and try to keep them a little bit lenient, or maybe do them like not on every frame, but maybe like every 5 or 6 frames or something like that. So you can go there and you can make sure that you're not bogging it down your system by doing tons of physics checks. Relating that back to the layering question, when you go there and you use physics layers, you're actually telling Unity or other game engines to bucket them into certain categories. So if I go there and I have like my default collision layer, my enemies, my allies, and my items, every time I assign them to a layer, they become part of a list. And whenever I want to go, and whenever you have that checkbox checked to say that enemies can collide with allies, it goes there and it has to check, does enemy 1 touch ally 1? Does enemy 1 touch ally 2? Does enemy 1 touch ally 3? Does enemy 1 touch ally 4? It has to go there and do all those checks, because that's the only way to tell if collision is happening. So by using those layers, you can go through and condense the amount of checks that Unity has to do, and that you can go through and make sure that your physics is being fast enough so that you don't end up slowing down your frame rate. And you can use those as different optimization techniques by saying like, oh wow, I have like 300 moving platforms. I can go there and put those into different layers, and so that I have less checks against the player depending on like what part of the level they're in. Those kinds of things. You can use those to your advantage too, to optimize stuff. Yeah, any more questions on layering or physics or anything like that? Got it. So, oh, sorry.
Is it better to create auto-generated platforms or just one big level? So like parallel to third?
It depends on what you're trying to get done. For this class and for most situations, I would recommend doing them in one big level, because your load times will be like, you have this one load time, and you don't have to worry about any other additional loading in the long run. Say if you're wanting to make it bigger, like Skyrim or open world game, insert title here, you'd want to go there and segment those levels into smaller pieces so that you can string them in and out so that you don't end up using too much memory. So if you end up planning on having like a more open world style game, that's where splitting up into separate scenes would go through and make sense, because you can go there and say, hey, I'm in tile grid 2-2, I'm gonna load the one above, the one to my side, one to my other side, one below, so that I have that loaded in memory in case the player walks in that direction, and I can take them out as they get further away. and so that I can go there and lower my memory load the whole time.
So like in 2D, if you have one big level, there will be like different scenes, right, throughout the levels. Like the player can like go anywhere into that big level.
You could, and it's a way to do it. It's just, I recommend just for simplicity's sake, I wouldn't recommend it for this class, but if you want to take on that challenge, you can. If you plan on having a really, really big 2D level. Like say if you wanted to make like a Metroid game, I would recommend that. Because like that's why they have like the loading doors in between so that they can tear down the old one, load in the new one. So for those, you might want to have like nice, distinct, like this is when I'm transitioning into a different spot. Those are good points to have that particular kind of architecture. Any other questions? Is there any other systems people would want me to go into more detail on? Okay, y'all just gonna make me continue improvising stuff. What's up?
Might be a big question, but what is the like #1 mistake that students make in Unity? So you could just kind of have like a public announcement, please stop doing this kind of thing.
That using fixed update and updating correctly, I see all the time, and that's the one that I think is one of the biggest killers. Another thing to be wary of, this is actually a pretty good thing to get into. So y'all see the update and fixed update, and those, as I was saying multiple times now, they're loops. But you're not seeing the loop, you're just seeing the method of the mono behavior or the class that you're working with. So because of that, you want to go there and make sure that this method can be completed pretty quickly. So something that I would recommend / don't recommend doing, go into a mono behavior, add a while true loop, and see what happens to the editor. It will freeze because the game's trying to go through and work on your mono behavior. It gets to your mono behavior, runs a while true, and it's like, it's telling me to just do nothing, and I'm stuck here, and I can't move to the next frame, and the whole editor will freeze. Because, sure, you're in a loop, but you don't want to make sure that your loop can finish. And so because of that, you need to always be aware of whatever I'm doing in my update, if it's really expensive, I might not be able to do it in my update. So if you want to go through and say like, I want to determine if there's these 5 objects in a particular configuration, and if they do, I'm going to spawn all these really expensive particle effects. That might be something you want to architect a different way, because that's a lot of checks, and if it goes through and it takes a long time to figure out where they are, then that frame is going to get longer, and your frame rate is going to get shorter. I mean, it's going to get longer, and your game's going to get choppy, and it's going to not be really presentable. So when you start abusing update and fixed update in the wrong ways, that's what ends up happening. Something to also be aware of is you'll see some convenient stuff in there, like find object of type or gameObject.find. Those are very, very expensive because they have to go to the hierarchy and check every single one in your scene to find out what that actually is. Because there's no magic to it. The only way to find out if something's in a level is to search the level. And you have to search the level from top to bottom to see if you find it. You might get luckiness the first entry, but that's not something you can rely on. So when you use those gameObject.finds or find object of type, I personally recommend don't use gameObject.find as much as you humanly can. Use find object of type or something like that. Try to put those in your start or your awake, because those are when the game objects first get created, and it might be before your level even starts. So if you do that way, you put all that burden of finding the stuff way earlier in your level, and so that the player might see like a little bit of lag on the first frame of the game, but then they're none the wiser after that. So you can use those things to sort of hide like doing those lookups and those really expensive, like, I need all my enemies to know where the player is at all times. So I'll go there and I'll find it, store it, the reference, and then never try to find it again because I already know where the player is. The players, that transform over there, they're not near me, so I don't care right now. But I don't have to go there and like every frame be like, ooh, where's the player again? I don't know where the player went. You don't have to go there and spend that cost and slow down your game. So that's another really common bug I see. Another common bug I see is, or not really bug, but just like anti-pattern, is not splitting them up and going through and putting just tons of code in one mono behavior. For a lack of better words, lines of code is not a really good metric to determine if code is good or not, but trying to make sure like a lot of your mono behaviors are down like the 1 to 200 category, 1 to 200 lines of code. Just because like if you keep it in that amount of time, you'll start noticing, oh, this is common, this is copied from over there. I can go there and take those out and put them somewhere else so that I end up having less surface area for bugs to show up.
Yeah. So one thing I wanted to ask you more about was, I know you'd mentioned the like Mega Man style platforming where you can kind of have your little toe on the edge and you're still there. So can you kind of explain again, how exactly does that work? Like checking that you're on a platform that way?
Gotcha. So when you think about it that way, think about to what they were working with back in the day. Because us being in 2019, we have a lot of luxuries that like people in the NES and Super Nintendo didn't have. So when you think about this character, so say I have this character with a box collider, and I have this terrain here. Back in the day, they just had pixels. They just knew that I was putting this pixel here, this pixel here. So they wanted to go there and determine a collision. They had to see if the pixel right here was touching this pixel, and if they were like, does this pixel represent a collision or not, kind of thing. So when it comes to doing that sort of in a more efficient way, you can use the raycast. So what is happening is it's shooting out these little lasers. And if you go there and any of these lasers return true that it's colliding with something that I consider terrain by using like the layers or the tags, by saying like, oh, I hit a game object, go check its layer. If its layer is terrain, I'm going to now tell this person to have 0 velocity so that they're not going downwards. Or if they're moving, I don't care what the X velocity is because they can be running to the side for all I care on this frame. I'm not going to stop them from running off the edge, but I am going to stop them from falling through the floor. So that's how they do it for this stuff. Something that, getting back to the point of some common mistakes I see, if you put colliders right beside each other, you can have some really, really funky things that happen. So say I have these two boxes right beside each other, and I have the player right here, and the player's in this box. So most video game physics is based off what's called a resolver model of physics. So what happens is that we have this player and we have a velocity for them. We know that they're going to be moving in this direction. What I'm going to do is I'm going to take the player and I'm going to put them where they would be depending on gravity and everything else. So the player's now down inside the terrain because I didn't know there was terrain there. I'm actually going to move them the way that the velocity told me to move them, which happened to be influenced by gravity in this case. So I'm now colliding with this box right here and this box right here. So what they will do is they will do a multiple iteration resolve. So they'll say, I'm gonna simulate you over here, and I'm gonna adjust for what the colliders say. Then I'm gonna move you over here, I'm gonna adjust for what the colliders say. So technically what's going on is you're essentially just flying around, and then you're getting adjusted out of what you're colliding with the whole time. That's how most physics systems are handling resolves. The weird hiccup with having them side by side each other is when you're doing this collisions, you have to resolve it per collider as you go. So let's say this is collider 1 and this is collider 2. If I go through and I'm right here and my collider is bumping into that edge, who do I resolve to first? If I resolve to number 1, it wants me to go up because I'm colliding with this side of the collider. If I'm colliding with number 2, I'm colliding to the side because it sees me colliding right here to my right. So if this guy goes first, I'm going to stop your horizontal momentum because you're heading to a wall. You bumped into the side of a wall, so I'm going to stop you. But to number 1, you're bumping with the floor. I'm going to push you up. So by having these two colliders right beside each other and essentially too close to each other, I have a non-deterministic way of determining your physics. So now your simulation is broken. Typically what will happen if people go there and build tiles of their game with just these squares and they're right beside each other, they're overlapping each other, you'll see the character move, and occasionally they'll like sort of trip, they'll get stuck like suddenly on a little like weird piece of terrain. And like anytime somebody's playing a 3D game and like you see like the plane becomes a mountain and then like you start trying to walk over that and like really weird stuff happens, that's because of these weird physics overlaps are happening. And so with that in mind, try to avoid using colliders that close to one another. An easy way to do that is just to make a bigger collider, because then you don't have to worry about this particular issue. In Unity, and for at least anybody doing 2D, I think GameMaker does it automatically. I want to say so. They have the tile map component that you can use. That if you go through and just build out the tiles of your level, and then they have a tile map collider that will look at the boundaries of the tiles, and then just build one giant collider for the whole thing, and make your life a lot easier. That didn't used to be there. I had to make this stuff manually myself. It was not fun. I would not recommend it at all. So that's another common incident I see. It can happen in 3D stuff too. Something to be aware of with 3D is that there's a reason why you always see boxes and capsules and circles and spheres and all that stuff. It's because if I know what the collision is like, and all I'm adjusting are like widths and heights and all those numbers, I can write really efficient code to handle those things, because those are just numbers I plug in and get answers from. If I go there and I have like this complicated, like 20-pointed polygon, that's something that this physics system has to take a lot more consideration of, and it ends up being slower. They end up being what's typically called a complex collision. And so those are the reasons why you see, if you ever end up jumping into like a bigger open world game and you turn on like collision, so like there's commands in like Skyrim and some of the other Bethesda games to see their collision, what's going on. You'll see like things overlapping, but they're mostly like squares and cubes and stuff. They're doing those to sort of cheat and get really simple physics to get the job done of what looks like complicated physics. Because you can go through and you can cheat it that way by saying, like, if I have a terrain here and a terrain here, and I don't want to make this giant mesh to do collision, I'll just put a little like square here that becomes a ramp and guides you to the mountain. You can use that thing to cheat it. Getting back to the cheating idea. So all that stuff is all together in one big web to suddenly match up and make a game come out the other end. Any other questions related to stuff like that? Okay. Got a little bit of time left.
You were about to say serialization, but you only interrupted
Oh.
me. Yeah, right.
So there's Unity is sort of the biggest one that I can talk about this with. And a good example of it is actually the demo here for the inventory system. So I was talking about the inventory system, right? And I was talking about that we need to go through and have particular items that exist. So by going through and trying to make sure that my code is simple enough and works well enough, let me just pull that up and it'll be a little bit easier to show you here. So let's look at our little guy. And let's go there and see the inventory they have. So I go there and equip all these things, and I also have like consumables here that go away, but I can swap them in and out as much as I want. So this is actually reparenting them to characters somewhere. Yeah, so actually no, I'm just doing, I'm switching out meshes for these different things here. So you go there and see, oh, just materials. Sorry, I haven't seen the code in like a year and a half. So for all these different pieces, I need to have a common way to define something that's going to show up over here. So looking at this code, there's a component, or not really a component, an object in Unity called a scriptable object. The scriptable object is something in Unity that it can be built up from a file, but doesn't live in my game. Prefabs are something that lives as a file that can be put into my game. So what's the point of the scriptable object? The point of the scriptable object is that I want to have a class that can do a behavior for me or give me information that I care about that will essentially tell something else to do its job. So in this case, when you look at like this armor or this weapon, all it has is it says that I'm a piece of armor or I'm a weapon, and this is the material I want you to apply to the mesh. So all that this good weapon has is a red material inside of it. Oh, well, and a little bit more. So the good weapon has the good weapon material, a good weapon image, a name, and a damage amount. So these things, these scriptable objects, you can use them to your advantage of like, why do I need to make a prefab for every single sword if I'm just gonna go through and change their damage value? I can have the same sword all over the place and just swap out what defines the damage for all the different ones in my scene. And so I only have to maintain one sword class, and I just have to make multiple instances of sword good, sword bad, sword awesome, sword evil. And I can go through and use those and just drag and drop them in the editor to get the different weapons I want. There's, I'll have to find it. I had another one for essentially like a Contra game. So like a Contra game where you're firing the gun, I had it where you could drag out and go from normal shot to triple shot, or normal shot to like a sine wave shot. Because all I do is I just say, hey, when you fire the gun, this is the movement behavior I want to give you. I just insert in a movement scriptable object, and I say, okay, every frame, this is the direction I want you to move instead of just straight. So you can use these things at your advantage to think about, for me to get the capability I want to plug in and pull out this particular behavior. If you see that thing showing up in your design, look at using a scriptable object to get the job done. Like, they also can be like, it's no different than like, if you're just using JSON to go there and tell a piece, like a website to put something on the screen. It's just, here's a little bit of info, run with it and do the job. I have to go there and see if I have it in this project or if I have it somewhere. Oh yeah, I do have it in this project. Sweet. I don't even remember how to activate it.
Oh, nice.
Let's see. So I got that here. So go to the pistol.
Oh no.
Let's change it to wavy fire pattern. And then, voila, I got a sine wave. So, all this code is out there available for anybody who's wanting to do that. And actually, I want to say the zombies are given, okay, they're actually using a different behavior for their movement type. Yeah, so these are all I had if you want to do like difficulty patterns, those are just essentially just a bunch of numbers that say how many enemies do I spawn or what's the average health of that spawn. You can also use those for scriptable objects to say, I just need to plug and play these values, and I just want to have a really simple way of doing that. Just drag and drop in those difficulty settings, and then you're off to the races. Or go through and say, on your main menu, I have the easy button and the hard button. When you click that, it loads the same level, but just inserts a different scriptable object. So you don't have to have two different levels for easy and hard. You just have this one file that tells you what it needs to do. So you can use those to your advantage too, to just, honestly, don't repeat yourself. But yeah. One last question I had was that, it's something I tried before, but I probably tried incorrectly with a previous class. Before, I tried making a Slack channel that people could jump in if they needed to ping me with questions. Now, like, I found out I dated myself, so now everybody's using Discord. Would y'all want me to make like a Discord channel and just post the URL so people can join in, and if y'all need any help, just ping me?
Yeah.
Cool. Okay, so, yeah, other than that, that's pretty much what I've got right now. How would y'all want me to spend Tuesday to be most effective to y'all? So some other classes, they've had me go around and talk to each team and try to just give y'all like, I'll just say like, hey, I want to implement this feature, how would you approach doing it? Or I could go through and walk through these examples and give y'all more coding like examples and just walk through the code on why I wrote things the way I did. Sometimes like one class just wanted me to straight just do a Q&A session. I want to be as useful as I can to y'all because y'all the ones who have the daunting task. I've already done the homework, so I got the easy ride to the rest of the class. So, what sounds the best to y'all? Because that's all I can do.
I think personally having like each team work on their own projects, and if they have questions about certain features,
Yes.
ask you about it.
Yeah.
Sounds
I
perfect to me.
totally agree.
Is there anything that y'all would want me to try to prepare for Tuesday? Because I do have all this other examples. I can go into more detail if y'all want me to like look at the GitHub repo and see if there's anyone that you'd want me to describe. I can do that.
Okay.
Yeah, whatever y'all want to do to make that most effective.
The only thing I can think of is just if you have any, can think of anything else that's like, you know, newbie mistakes that you want to avoid or something like that. I think we've covered a good amount, but you know, if there are any left.
Yeah, I'll go through, he was saying that, go there and do like a quick segment on just like some more of the like newbie mistakes that I've seen before. I'll go there and I'll try to see like, look at some of the older projects and see if there's anything that I'm like, I remember them having difficulty with this, and I'll see if I can scrounge up anything that I didn't cover today. for the most part, it's once again, learn how to use the correct update, learn to use the hierarchy, learn to build stuff out in components, and colliders are messy, use them carefully. That's the main, like, big ones that'll be 80% of your trouble. All right. Other than that, thank y'all for sitting through my improv session, and have a good day.